Hi, my name is Pankaj. I work for Booking.com in Amsterdam, and I'm going to be talking about database management and other observations. I just got static from this laptop, so I'm going to move away from it. So, a little bit about me. I've been doing Linux for a while. At Booking, I work on systems issues, essentially figuring out infrastructure issues or more complex installations, which are my main expertise is in large-scale systems because I've worked in the past with big companies like Yahoo, Monster, Flipkart. I understand. And I'm not really a DBA. So take whatever I say with a pinch of salt. A little bit about you. How many of you guys have used Salt before? Everyone. What about custom grains? Yeah, nice. And reactors? And Salt API? Okay, so there's something new you can learn. So what we're going to talk about today is how we provision databases, how we manage them, and how Salt is involved in this whole process. Part of exploring that, I will talk a little bit about the booking infrastructure, history of how we got to Salt, like I said, how we do databases, and other limitations and issues that I have faced. And whatever I'm talking about is obviously work in progress, so it's not perfect, so excuse me. Booking.com is a hotel management website. It's pretty big. We have 2 offices. The headquarters is in Amsterdam, and we have an office in Seattle here in US. I work out of Amsterdam. We have a fairly large setup. We have around 5 data centers. 2 very large ones with 6,000 plus physical boxes, and a 3rd large one is on the way. So we have a large setup that we need to manage. Mostly the setup is Linux. There is mostly CentOS. There is a little bit of RHEL and a little bit of other stuff, but it's for all practical purposes, it's Linux. And we are heavy users of MySQL. And 50% of the hardware is MySQL. We have large replication chains with hundreds of slaves. We also denormalize a lot of data sets and put it in shards so that we can get stuff really fast. It's essentially when you're talking about booking hotels, we have customers all around the world, and there's a long tail. So the data sets are really large, so you have to make it available really fast. And because you're talking about bookings, you can't really do it with cache. Because if you are using cache, it will expire every single time somebody makes a booking. So hotel rooms have to be real time in a RDBMS, but you can flatten them out. We also use a bit of SAN, which I will explain later. So how we got there? So historically, there was Funk. I don't know how many of you guys know Funk. Some of you are shaking heads. So Funk is it's like you can do large-scale random command execution using Funk, and it's good at doing certain things. So Funk was being used to do to make Git hooks, to take stuff that is in a Git repo. If it changes, do something, and do Puppet kicks. If you want to make Puppet run itself on a particular box on demand, you do a Puppet kick, and ad hoc task execution. Also used for deploying and Git hooks, like I said. And Funk was also very good for managing PCI resources, machines you don't have access to, which are behind a closed network and which are behind a firewall. So my main responsibility was to get the funk out because of certain reasons, which people who have used funk will know. So funk is, as we all know, is a dead project. It's no longer in development. It has certain issues with running long, large queries. So if you have 5,000 boxes and you want to create a new file, on all of them, funk will take 2.5 hours, which is not very nice. So the idea was to replace funk with something nice, and we get here. I don't really have to talk about why we are doing Salt, because we are at SaltConf. So, but for me, I did analysis of all the stuff that was around there, and Salt stood out in certain manners. Like it may not sound reasonable to you, but to me, these things made sense. Because is asynchronous, because it used the pub/sub model, it made sense to me. And we also wanted to have a second way of managing our resources other than SSH. So Ansible was not really preferred. And Salt was really impressive with the task execution and report age arsenal that it has. The fact that you can plug returners, the fact that you can write a module and get the output in JSON, YAML, whatever have you. And it's simple scripts that you write, you can plug into Salt, and they become really powerful. Salt CP performs the Salt distribution, file distribution tasks really easily. We continue to use Puppet for configuration management. As you can imagine, we have a really large setup, and I think the puppet.git is, I think it has directories, which if you do ls, it scrolls on your keyboard for hours. So it's a really large setup to move. So we're not doing states as of yet, but we are continuing to use Puppet. So this also presented an interesting challenge to have Puppet and Salt run together, which was interesting. We also use custom grains, reactors in Salt API to replace funk use cases. So I'll quickly go over my design. We have a master of masters. We have a syndic ring. There are multiple other masters who are subscribing to the master of masters. And then there are some standby masters and failover masters. This is not a highly available setup. However, it's very easy for anybody to fix if a master goes away. So I'll tell you how it happens. So essentially, if we go back, or actually I can go further down, there is a diagram. So here you see there is this master of master. It has a peer, and so this black line just explains that these two are different data centers. So you have a master of master here. There is another one here. There are local masters here. And this is a PCI environment, and it has a local master here. You can imagine there could be another data center, and you can repeat the same setup. So it's highly scalable. You have one central master. If this guy goes and falls over, this guy gets promoted to be the master, and everything just keeps on going, right? If this guy dies, there is another one. So this setup is reasonably highly available. So essentially, the idea was not like I could have designed a system which is self-healing. Even if one master dies, I could create complicated replication chains and make it happen. But the idea was to keep it simple. So if it breaks in the middle of the night, the guy who finds out can fix it easily. We use 0MQS transport, and keys are shared with Puppet. So we use the same public keys as Puppet users. So I don't have to do key management. It is already there with Puppet. I use the same ones. And the syndics and the masters all find out who my master of master is, and all of that through Puppet. It's really simple. Multimaster provides failover for minions, and we use the PyPy releases. So what I mean is, if you see these are the minions, they have multiple master. If one of them falls over, they can be reached from the other guy, right? So that makes it really easy. SaltMaster configuration, sorry.
So they have like 4 masters?
Yeah, so this minion has 2 masters. This minion has 2 masters. And the PCI minion has also, but the diagram doesn't depict it, but has multiple masters. The master config is really simple. It's, I think the only different thing is to have some file roots that help me populate grains and some module directories. Other than that, it's just standard. So roles is essentially a hangover from Puppet world, where you have a bunch of nodes that do similar things. So more appropriately called node groups in Salt. I just have a simple script that takes all the mapping between machines and their roles and dumps it into nodegroups.conf. This is a really simple format. If you read it in the documentation, it says node group name : members. So if you generate this periodically, it gives you great flexibility. So let's say you have a node group called app, right, which has all the application web servers, right? So somebody can do something like salt-N app command.run something. So you can target all the machines that are similar very easily. We use this. We also use custom grains. So for example, you can use custom grains. You can have custom grains are essentially simple Python scripts. You can place them in grains. And whenever you query for grains.items or anything, it runs the script and caches the output. You can do a clear cache to get a fresh output if you like. So essentially, we can put whether this machine is in rotation or not in custom grains. We use this to tell if this MySQL machine is a primary master or a cold standby, and it's useful. Because I'll show you why it is useful. In grains, we can also store RAID and storage information and fiber channel information, which is helpful when you run a large SAN. In custom grains, we also store the database type, which is it a master, slave, or intermediate master? Puppet facts come for free. I've also written a small Python script which takes all the Puppet facts and converts it into grains, which is very useful. We also do a reverse sync up to our CMDB. So you take all the grains and you query them all. This is really clever. You query them all and put it back into the CMDB. So CMDB is always has live data. It's not like tailing behind. So here are some examples of my custom grains. Here you can see this grain is called storage. It has essentially this is one of the HPA cards. It tells you which switch it is connected to. Here's another grain which says all the switches this guy is connected to, all the filer this guy is connected to, WWPN if you know, SAN, this is the identifier. It's sort of like a MAC address for HBA adapters. Rate controllers, this is disk info, and these are some booking specific grains which you can use. So essentially, you can put any sort of data in grains, and you can query it using salt-g, and you can do really cool stuff with it. For example, this use case, if you have ever run a large storage network, you will know it's not easy to figure out which. It seems like really simple thing, tell me which switch my box is connected to. But it's not really easy to figure out because in SAN world, you have WWPNs, WWNN, the switch has its own WWNN, the filer has its own WWPN, and the switch uses something completely different to communicate. Switch runs a name server because WWPNs are really large, so it chops it up into 64 bits. So if you're debugging this, it's not a very nice thing. But this makes it really simple. Here you just say -g store filers, filer prod 204. It just tells you, give me all the switches filer prod 204 is connected to. So this will result in all the hosts that are connected to filer prod 204 and give you all the switches these nodes are connected to, which is really sweet. CMDB and grains automatically reflect production situation. So essentially what you want to do is, this is how it does it. What you want to do is, let's say somebody removed a cable and plugged it into another port on a switch, right? Now your CMDB, if the DC engineer goes and writes it, it will be there. But if he forgets to write it, well, now your CMDB is out of sync. So you should not rely on human beings to keep doing this. So what you do is, you essentially query the data from from the live environment and push it back into the CMDB. So how we do it is, we have a scheduler which runs a scheduled task on the minion, which fires an event on the master with an option called with grains true. What this does is, it gives all the grains to the master, right? Once this event is received on the master, it fires a reactor which launches a runner which essentially says, okay, do I have these grains from this guy? If I do, is there a difference? If there is, update CMDB. Otherwise, just throw it. Like this is really powerful. It's a very simple, small thing, but now your CMDB is reflecting your live situation, and I can fire this event every 5 minutes, every 1 minute. It costs nothing. What about salt reactors? Reactors are really cool. We use salt reactors for Git hooks. Like if somebody commits a change to puppet.git, it pushes it to the puppet master and calls a puppet kick. Essentially, if I make a change to puppet, it automatically deploys itself. I don't have to do anything. DNS. If you make a change to DNS.git, same thing. It just deploys itself. You don't have to do anything. Grain sync. Essentially, whenever a minion restarts, sync the grains back to the master. There's a reactor for that. This is like the tag for the reactor. This is a really nice reactor that I wrote. What it does is it creates a zone file for fiber channel switches, which is really cool. I'll show you what I can do with it. But before that, I will tell you how we do databases. Essentially, we have many masters with local storage and some masters which are on SAN. And we have materialized data sets, like I said, which are denormalized data sets, which are sharded. And we have hundreds of slaves. We have cross-DC replicas so that if a data center goes sideways, we can always move to another one. How many guys have experience with SAN? Okay, good. A little bit of SAN 101 if you have no knowledge. To make a SAN work, you need to have fiber channel switches. You have appliances of your favorite provider. You give block storage, which the box mounts, and you use Multipath on Linux to create multiple paths to the block storage. So essentially, you either have either you can have multiple fiber networks that your box is connected to, or you create like a chain ring, and Multipath can help you go through to the block device. So we use Salt API to call Salt commands, and this helps us do a lot of work. For example, we can do storage allocation and automation, and we can also do a lot of everyday DBA activities by interacting within multiple masters or slaves and stuff. Salt API is really simple. There's only one thing though. The REST Cherry Pie latest version has a bug and SSL doesn't work. This ate 4 hours of my life. So I'm telling you, please make sure you downgrade Cherry Pie before you try SSL. Everything else is really simple. You have a self-generated key, and essentially you have to create. Another interesting thing about Salt API is you need to have a authenticated user in order to run Salt commands, right? So either you do it with LDAP. I chose to do it with PAM, so I created like a local user on the Salt master and gave it everything, all privileges. But you may not want to do that. But well, YOLO. So Salt API, essentially, the problem is you want to create a master with a remote storage. So this involves a lot of things. You need to create block devices on your filer. You need to create zones on the switches. You need to mount it on the box. So use Salt to automate all of this. Essentially, use Salt API to make calls to NetApp and create learns. Using NetApp has this REST API sort of thing. It's called WFA. So you can make calls to this guy, and it will create. You can create iGroups. You can create learns. You can create NFS mounts. All sorts of things. Fiber channel switches, however, do not have this. We use Brocade, so Brocade doesn't have this. So I just wrote like a simple Python script that uses SSH library to SSH into the box, do things like create a zone, add members, stuff like that. And then I call these through Salt API. So I call this through Salt API, and Salt helps me wrap this whole thing up together. So I can make one call saying I want storage node. It makes all the other calls and gives you back the result. So essentially, there's a Puppet module which creates a mount point and creates a zone, creates learns, and mounts it. The next thing is the TBA tool. Essentially, it's a wrapper around all the MySQL commands that you will see. And there are some other scripts that people have written all over a long period of time. So essentially, to get to rsync directories, to get slave status, to initiate backups, to restore, to other fun tasks. TBA tool currently mostly uses Func still because it's getting ported to Salt API and to use reactors for these use cases, but it's work in progress. Some issues. It's very easy to break Salt minions everywhere. For example, if you push a bad grain, that's it, you're done. Then you can't really get the Salt minions back, because if the Salt minion crashes on 5,000 nodes, you have to somehow figure out. So this is a big issue. I have essentially hit this a couple of times. It would be really nice if there is a way to have a bare bones or a minimal Salt that you can start without grains or whatever, which will continue running, which will let you self-heal salt. Because, pardon? Yeah, essentially you say run salt without grains, without this, without that, without modules, without custom stuff. Just run in your own shelly way. That will be really nice, because what you can do is then, let's say the salt minion crashes like 3 or 4 times, or you can have a number of times. It just goes into that mode, and then you can figure it out. Problem with, I think Salt API just got integrated into main, so I'm not really complaining, but it's really slow. The reason I haven't moved most of the TBA Tool stuff to Salt yet is because Func is so much faster, and this is not something I would like saying. But yeah, it will be nice if Salt API is faster. I think it has something to do with my environment as well, because as you saw, I have like Syndic I have a master of masters, I have Syndics, so the response time of a minion coming to intermediate salt master, coming back to the master of masters, it takes a long time. So maybe I need to do something different there. There is a bug which says minions crash if one of the master is missing. So multi-master, you can't really run multi-master if this bug is not solved. Reactors also don't work very well with multi-masters. Simple reactors work, like auth. If you want to have a reactor on auth or something, it will work. But if you want to do like complex tasks that involve multiple machines, reactors don't fail. I have opened all these bugs, by the way. Node groups and grains are mutually exclusive. So essentially, you can't say, give me all the, in this node group, give me all the boxes which match this grain. You can do either. So that's also a pain point. That's it. That's all I have to say. I want to say thank you to everybody who hangs out on #salt on Freenode, because when I started, I had no idea what I was doing, and all the guys here were very helpful. And Booking.com and SaltStack for inviting me here. Thank you. I'm Spoonman on the interwebs. Thank you. Questions?
Can you go back over the setup? Because it sounds like at least one more interesting Syndic Multimaster thing I've seen. And that's like,
yeah, so my idea was to essentially create a Salt setup that was highly available and self-healing. Actually, the first design that I had created was even more complex than this. It had 2 replication chains. So these masters were independently connected to their own masters. So if one chain died, the other chain could take over. But it was too complex for me to even explain to others. So it would have only been in my head. So I thought that was not a great way forward. So I simplified it. This essentially, like, if this master dies, there will be an issue for a while until you move this guy here. So since we are still using Puppet, I have put this stuff in Puppet that, okay, this guy is the master of masters. So if you change that in Puppet, all of these guys will reflect themselves, right? When we move to managing stuff with salt states, it'll be similar. You update the Git where the salt state is, and one guy will take over, essentially that. Because all you need to do is run Syndic on these boxes, right? The intermediate masters, they need to know who the master of master is, and this guy essentially does nothing. All it is doing is it's communicating to these masters, right? And these masters are independent as it is, right? Because if this master dies, all I have to do is start Syndic here, and these guys can reach. So one of the problems that I have faced is duplicate. Like if you run Syndic on both the Syndic process on both the masters, the minions will start getting duplicate process job IDs. Like the jobs will get duplicated, right? Because Syndic is really stupid. It just publishes stuff on the master. It doesn't really know anything. So I think Mike told me that they're fixing this. They have a patch which is going to figure out that this JID has already been executed on the minion, and we're just going to ignore it. So which will be really nice. Then I can run Syndex everywhere. Yes, please.
So is there any way you guys are managing box, like referencing Puppet and Salt together, like managing Puppet using Salt or using?
Yeah, Salt is not being used to essentially do state management yet, but Puppet does call Salt commands to do things.
But do you use Salt for Puppet forms? Like, you send something to Salt master, update the states using the
Yeah, so all the setup on the SaltMaster, the /srv, all the grain files, that stuff is in Puppet. Puppet maintains those files, right? Even the configuration of the masters is in Puppet, right? I mean, I could have done it with Salt, but I didn't want to rock the boat before Salt proves itself. So we are using Puppet heavily, so it'll be a slow change. Like I really like how Salt does state management, and I would like to do at least the states of Salt and more stuff in Salt, but it's going to take time.
When you set up the initial, like let's pretend you don't have like this gigantic infrastructure, but the simple thing, like you have a master and a slave, David, I think you said MySQL. So when you bring these up, how are you doing that initial instantiation? This guy's the master, this guy's the slave.
Oh yeah, so that stuff comes like essentially when we have a CMDB. So the master servers are physically different because they are attached to SAN. So the guy who's going to create a new master is going to say, I want a master box. So the DC engineer will patch a box. If it is already available, it will just initiate itself. Like we have a interface where you click and say, I want a master, and it boots itself, and like it does a PXE boot, DHCP, it finds itself, it comes to you. Then, yeah, so in the CMDB, you can say this is a master, this is its pool name, and all those stuff becomes grains. So like the stuff that you put in CMDB becomes grains, and you can essentially, like because I take the factor stuff and the custom facts and I put them into grains, so it becomes grains. So using the TBA tool or whatever, you can figure out that, okay, this is my master. So it shows in a grain that this is the master, this is the secondary master. So you can do things with it. And the automation for creating the boxes, that will use this as well. The provisioning, pardon?
Basic provisioning is right now done using Puppet.
The basic provisioning is done by Puppet, yes.
That sets up Salt.
Yes.
But sorry, I'm thinking a little further like, so, okay, you provision the master, right? CMDB, all that, or forget what exactly you said, but something like that. And then how do you get the schema load in, and then how do you tell the master, slave, this guy's your master, and you need to start at this point in the replication?
Oh yeah, if it is a new chain, you have to set it up. But if it is an existing chain, you never set up a new slave, you set up slave from existing slave. So there is an automation for that. There's a script, you just say, give me a new slave. It will essentially create it will install, it's essentially Puppet, right? It will install MySQL, it will connect to the other guy, it will download the data, it will start MySQL at a certain location and stuff. So that has nothing to do with Salt.
Oh, okay. I thought it was.
Yeah.
There was a slide about the scheduler that you were using to sync the greens with.
Oh yeah.
So there's something.
This one.
Yeah. So I don't understand React very well. So I just wanted to ask. So what if you had done the scheduling on the runner itself, asking green.items everywhere, and then doing the diff and updating?
Yeah. So okay. Yeah. And the question is why call event? Why not just do runner directly, right? So the thing is, this happens. This is very distributed. So all the minions, there is a scheduler to call an event on all the minions. So the minions will themselves call an event saying, okay, hi, and they send all the grains to the reactor. And the reactor essentially calls a runner, which is basically, why do it is with runner is because it forks. So Salt is free now. So you can essentially fork a new script which does a diff between what was reality and what is the new reality. If there is no difference, then no problem. If there is a difference, then update CMD. This is a expensive task, right? You have to connect to a REST API, you have to update it and all that. It may fail. So I don't want to do it with Salt. I would just want to get rid of it.
You don't want to directly send all the data via Salt.
Yeah.
Do you use any kind of randomization on the scheduler and the minions for when they should run, or do they all try to synthesize?
No, they don't try it at once. There is randomization there. Like the event itself will be run. Thank you.